Hello guys, welcome back. So this will be the last part of our functions and we are starting with recursions. A recursive function is a function that calls itself usually to break a problem down into smaller versions of the same problem. Like just complete the decorators and I want to create a function def. So this is the code where here there is a function known as def and countdown. If n is less than 0, it will print lift off and it will return, and it will print n at last, and countdown is 5. So let's try to run this. So here the output, if you forget the base case or your recursion case never actually approaches it, you get infinity recursions and Python will eventually raise in recursion error. Let's see what happens. So you recognize the error if you ever hit it by accident, like if you done any mistake. So let's create a function with the infinity cases. I want to just name as broken and n, and I want to print n, and I will call the function again broken n minus 1. So there is no base case, will never stop, like it will never stop, it will just go to till minus n. It won't stop. So I will like use try an error method just to get to broke this exception. Broke, I will give a number 5 and accept recursion error as e. I want to print the error. Okay, so here it is a broken code where it will run till infinity, like it will go till -2 -5. So recursion depth limit. So let's run. Okay, there is a runner name broken is not defined. Okay, what's not defined? Let's try to save and let's run again. Okay, see here it will go still infinite. It is a broken code here. So maximum. So in Python, like Python has a built-in recursion depth limit, like usually 1000, especially to catch bugs like this before your program caches your computer memory. Now let's look at the classic teaching example factorial. It has a depth of like 1000 and believe like above 1000 it won't go, so it has a maximum depth as. So let's go to another. So this is the thing we should remember, it has a limit to do this. And next I'm trying to build a function which will give me a factorial of a number, like def give a factorial and n. If n is less than or equals to 1, it should return 1, and it should wait, why it's getting too much. Okay, it should return 1, or it should return n into factorial of n minus 1. So I want to print factorial of 3. So factorial of 3 is 6, like 3 2 is 6. So let's run it. Yeah, it's 6. I'll just clear the output and run again. Yeah, 6. So I will check for another numbers like 9. So it will just go like 9 into 8 into 6 into 5, so on. Let's take the like step by step before like it will happens. Let's try another number, like giving it 0, because there is 0 is 1, because factor of 0 factorial is always 1, because here there is a base case where it will stop running here. So that's the good thing in recursions. And we can call the functions as many times as you can until the statement was run. Okay, each call waits for a one below to it finish before it can complete its own results. This stack of waiting call it's literally called the call stack, and it's why deep unbounded recursions can run out of memory. Like we can use Fabonic, another class, and there is another thing in recursions known as Fabonic. Fabonic. Okay. It's an another classic example of recursions. Like let's just create a function. It's not it's like even though we call let's pass an parameter n, and if n is less than or equals to 1, it will return n, or okay, it will return n, or it will return fa- Fibonacci of n minus 1 plus Fibonacci of n minus 2, and let's call the function in the range like in a type like in a loop. So like for I in range, let's give a range 10. I want to print Fibonacci. Okay, it's not Fibonacci of I, not the I, and I will end with a gap. So here end is equals to gap. It will just give a gap after every run, so we can see the difference what is happening. And I want to print after every like loop was completed, I want to give a gap. So this, let's run this code. So here we can see till 10, it's I got the numbers like 1 1 plus 1. Fair warning and a genius important lesson here. The Naval Fabric implementation is extremely slow for large numbers because it recomputes the same value over and over again. Let's prove it and fix it because it's let's starts. How long it took? What that took just Fabric 30, and it gets dramatic worse for large inputs. So these are the like recursions, and let's try one more thing in recursions. Let's write a recursion function. Like its name should be some digits and returns the sum of all digits in the positive integers. For an example, like def sum digits n, and okay, it should have an underscore, and if n is less than 10, it will return n, or it will return n divided 10 plus sum of digits, and okay, my mistake. So I want to print some numbers like some. I'll just copy it for good thing. Okay? So I will print numbers like one comma no 1 2 3 4 3 4 5, or any sum of number only one number, or like a normal number 999 or 4 nines. One is 50, 5 5 5, okay, 15, one is 7 and is 9 4 36. Okay, it's working. So here basically what happens is like it will take the first digit of the number, like, and here everything is like divided by 10 and the last digit will come apart, and it will be here, and another it will read, so the number will be divided, and this number, like from 4 to 1, this number will go here, this number will go here, and the 4 will be left. So like this, 1 after 1, it will run for like 5 times just to add this number. So these are the recursions in the function. We already have learned and things, recursions, and so these are the some interview questions we have seen, uh, like someone will ask. So let's simplify to the questions that come up most often in Python function related news. So you will fully prepared. So what's the difference between print and return? Of course, we know print displays output in the console, but the function still returns none unless you also use return. Return sends a value. Like, let's see an example. So let's take this, and I will just remove this, and I will okay. So I want to get function def, and there will be like, say hello. It won't take any parameters, and it will print hello. And this is a small function. If I want to call the function, I will just say hello, and I will just read bracket. So there is none because there is nothing to go here. I didn't even add any parameters. If I run this code, okay, I can't run. Why can't run? It will say hello, but if I want to like add, if I want to return, if I want to change the output as I need, like if there is a function to add numbers, so it will just add, and it will take out inputs like 1 comma, like a comma b, so two inputs, like two parameters. It will, I want to print a plus b, or I want to, and I will just do another function. Here it is add elements, so just to get confused, and it will return a plus b, and here like I can just call the function add 3 comma 4, but here I should I should write either like this, print add element 3 comma 5, or I should take a variable y and I should print like that. So these are the difference between, either way we are getting same outputs. If I want to add another number here, so I'll use this type of functions known as returns value. So these are the major difference between them. So let's try to complete as fast as we can. What is the difference between a parameter and an argument? A parameter is a name in the function defining, an argument is an actual value passed, and when the function is when they call the function. Which of the Why is using a mutable default parameters like are dangerous? Because their values are evaluated once at function defining time, none of our every call, like not for every call. So a mutable default gets shared, and emulator scores all values that doesn't override it. Like we can use none, as I said in the previous time. We can use none for better, like just a default or create mutable object, And we know the difference between drags and quacks. One is used for positional arguments, and another is used for keyword argument, and it is used for dictionaries, and it is also used for tuples. But both let the function accept flexible variable numbers of arguments, like the number of keywords we don't know. So then we'll what is LGB rule? In order Python searches for the variable name local encoding, L for local, E for enclosing, and G for global, and B for built-in. Stops at the first scope where the file name is found. So these are the few questions they have asked. So let's go through that. What is the need of global and non-global? So global basically just think. Global is a variable name where it is defined everywhere in the code, even in the loop, outside the loop, and everywhere. Like it is resize a variable from the outer scope. Where non-local is a like a variable where it's used only in the loop, just like a loop inside anything. What's a cursor? A function that remembers and can access variables from its enclosing scope, even after the outer function has finished executing. What is a decorator? What is the use of functional wraps inside one? A decorator is a function that takes functions and returns a new function that wraps extends its behavior. Function 12 preserves the original function like slash slash name or slash slash dog, which would otherwise be overridden by a wrapper function once metadata. What is the difference between return and yield? Exits a function completely and sends back a single value, but yield pauses the function, sends back one value at the time, and then resumes later. Like at last time we have seen, if there is a return, if there is a return here and this is valid, and it is returns a value, it will skip this all, like till this six questions it will just skip the questions. But yield is not like that. Like yield will pause for a time and it will continue with this type of function. So it is a use when you want get more outputs. These are the difference between returns and yields. Why uses a generator instead of returning a list? Generators are lazy. They produces values one at a time on demand using far less memory, which matters a lot of large or infinite sequence. Limits compute and stores every value on phone. So these are the functions. These are the type of functions we have learned so many things right now, and we have seen like we have no functions. What is the function? Parameter, argument, positional, keyword, on like type, hint, lambda. We have learned so many things. So these are the things we have learned. So thank you guys, and let's see you on another YouTube video. And bye bye.